Hello, welcome back to my recorded classes. So, this recorded class, we are doing a tutorial from the topic section number 3.2, 3.3, 3.4 and 3.5. So, some of the questions we are just solving here. So, let's start the content here. So, this is from the course discrete structure section number 3.2 to 3.5. So we will go to the first question here. Question number 1. For the given digraph representing the relation R on the set A, B, C, D, find the following. A part, the relation R. Okay, we need to write the relation R in terms of ordered pairs. And B part is what is the matrix representation of that relation. Okay, so this is the question from 3.3 section number 3.3. So let's do that question. So here on this side you can see one graph here, one digraph is given. Digraph means directed graph, correct? Its edges are directed edges, direction is there, correct? So represent this relation by using ordered pairs. So this relation is on the set B equal to set A, B, C, D. That means the vertex of this graph, you can see the vertex of the graph is A, B, C and D, correct? Now represent first the relation R, find the relation R. So we can answer the first part of the question. R equal to, the relation R equal to, what we are doing, just to check each vertex. Okay, what are the edges? Okay, going from each vertex first we write. Okay, so first we are going to the A vertex. See, A vertex we have one loop here, correct? We have one loop here. So that loop means it is starting from A and ending at A. So ordered pair A and A. That is the first element, first ordered pair in that relation, A and A. Comma. Now from A, what are the edges going out, correct? So this edge is going out, see, because the direction is coming like this. So from where to where, that one from A to B. So second ordered pair is from A to B, ordered pair A to B. We have one ordered pair there, A to B, one edge is there from A to B. Now only that two edges from A, from the vertex A going out, only first we are writing going out only. Okay, now we will go to vertex B. Okay, vertex B, what are the edges going out? We can see one edge is here, correct? One edge is this one going out from B to C. So I can write B comma C, ordered pair B comma C, only that one going out, not going in. Going in, it will write in another vertex. Okay, so going out only B to C. Now we will go to C vertex next. Okay, we will go to the C vertex. This is the C vertex. So what are the edges going out? You can see C to B, there is one edge going. So we can write C comma B ordered pair, and from C to D one edge is going out. So we can write C comma D ordered pair, next ordered pair in that relation. Now similar way we can go to the vertex D. From vertex D, what are the edges going out? We can see one is here from D to B, correct? So we can write D comma B, first one, and the second one from D to A, correct? From D to A. So we can write ordered pair D comma A. So these are the elements in the relation R. So I hope you understood the first part. What are the elements in the relation R? Okay, or write the relation R in terms of ordered pairs. So all the ordered pairs we are covered that one, correct? Now we will go to the B part of the question now. Question B. What is the B part? Find the matrix representation of the relation R. Okay, that means ordered pair relation we are written ordered pair here. Same relation we are representing in matrix representation, or 0-1 matrix or binary matrix. What is the Boolean matrix? We can write that one, correct? So we can write, so matrix of relation always we are representing M R. M means the matrix, R means under the relation R. So what is that matrix? We can see here. I am just writing that matrix here. So what are the elements in this set? You know, A, B, C and D. That means the vertex of the graph is A, B, C, D. So we can write A, B, C, D here for better understanding, and top also we can write A, B, C and D. Okay, now each edge, okay, we can write number 1 Boolean matrix. If there is no edge connecting two vertices, we can put it 0. So what is the first edge? We can see AA, correct? AA. So from A to A there is one edge, so we can put it 1 there. Okay, AA we can put it 1. That means the row A and column A, that is AA, put it 1. Now next one is AB. So from A to B we can put it 1, number 1, because there is one edge there. Now B to C, there is one edge from B to C, so B to C we can put it 1. Okay, now next one C to B, there is one edge from C to B, so we can put it here C to B 1. Then similar way we can represent other also. Next is CD, so C to D there should be one edge, and DB, so DB is here. Then DA means it is here, correct? All other position we can put 0. So 1 1 0 0 here, and 0 0 and 0 here, and here 0 0 here, 1 1 0 0. Okay, so this is the matrix representing that relation. So we can find, we can write easily that one, what is the matrix representing the relation, or matrix representing that graph. This is what we are calling the matrix. Okay, or we can say 0 1 matrix or binary matrix. Okay, 0 1 matrix or binary matrix or Boolean matrix, we can say that one. Okay, so I hope you understood the second part of the question. So each edges put it to 1, if no edge put it 0. Okay, now let me go to the second question, question number 2. Question number 2 is from 3.4 section. Use the method of computing the matrix of relation. Okay, use the method of computing the matrix of relation R star to find the transitive closure of the relation R. Okay, to find the transitive closure. This is what our question. Find the transitive closure of the relation R. The relation is 1 2 2 3 3 1 3 2 on the set A equal to 1 2 3. That means this is a relation defined on the set A equal to 1 2 3. Just to find the transitive closure. Transitive closure means we are representing R star. Okay, so transitive closure of the relation, transitive closure R star we need to calculate by using matrix of the relation. This method, matrix of the relation method. So in 3.4 section, all of you remember that one. For finding transitive closure, we studied two methods, correct? First method is matrix of the relation. By using matrix of the relation, we can calculate the transitive closure. And the second one we studied the Warshall's algorithm, correct? Warshall's algorithm, we can find the transitive closure. So here this question, by using matrix of the relation, just to calculate what is the transitive closure of the relation R on the set A equal to 1 2 3. So we will do that question. We will go to the question. So first represent our relation by using matrix. That is the first step we need to do. Just to write what is the matrix of the relation MR equal to. You know how to do matrix of the relation. Already we did one question just before. So you can see what is the set here. Set 1, 2 and 3. This is the set here. So I am writing here 1, 2 and 3. 1, 2 and 3 here. Now represent the relation by using Boolean matrix. So first element is 1, 2. So I can write here in the 1, 2 position, I can put it 1. Okay, 1, 2. The next one 2, 3. Next element is 2, 3. So in the 2, 3 position, I can put it 1. Then next one 3, 1. So 3, 1 position, I can put it 1. Then next one is 3, 2. Okay, so 3, 2 position, I can put it 1 here. All remaining positions, we need to put 0 here. So 0, 0 and 0. Here 0. So this is the matrix of the relation, correct? MR equal to matrix of the relation equal to 0 1 0 0 0 1 and 1 1 0. Now how to calculate the transitive closure by matrix of the relation? You remember that means matrix of the transitive closure MR star equal to what we need to do first, MR or MR power 2, correct, or MR power 3. This is the rule for calculating the transitive closure by using matrix of the relation MR power 3 here. Okay, so MR or MR power 2 or MR power 3 up to MR power 3, because you can see this set we have 3 elements 1, 2 and 3. We have 3 elements. So we can say MR power 2 and MR power 3 up to 3 we can calculate, because the set having 3 elements we have. So we will find these 3 first. First we need to calculate what is MR already we got now. Now we calculate what is MR power 2 and what is MR power 3. Boolean matrix that power 3, correct. So first we will do what is MR power 2 here. Okay. So I will calculate here MR power 2 here. Now MR power 2 means how we are doing MR Boolean product MR. That means MR multiply MR. Okay. Product means Boolean product because it is binary numbers. Okay. So we can MR Boolean product MR. So what is MR here? MR means 0, 1, 0, 0, 0, 1 and 1, 1, 0 Boolean product. Okay. Circled dot product or Boolean product. Again MR 0, 1, 0 and 0, 0, 1, 1, 1, 0. Now we need to multiply these two matrices here. We need to calculate the Boolean product. All of you know that how to calculate that one. For example, this is the row number 1, this is the row number 2 and this is the row number 3. Second matrix we are taking column number 1, column number 2 and column number 3. Okay. Now first what we are doing, the first row just multiply with the first column here. Okay. First row multiply with the first column. So I will show here some of the steps. Okay. Remaining steps you can do. So first I am doing what is R1 C1. First row multiply with the first column. Boolean product only, but we can study like this easily. So first number here multiply with the first number. First number here multiply with the first number. 0 multiply 0 means 0. Or okay, second number multiply with the second. 1 multiply 0, that is 0. Or third multiply third, that means 0 multiply 1, that is 0. Correct. So 0 or 0 or 0. Okay. All of you remember what is the OR operation. Correct. What is 1 or 1? Correct. And 1 or 0 means also 1. And 0 or 1 means that also 1. 0 or 0 means the value is 0. Correct. So here what it is easy. All the cases answer is 1. At least 1 times 1 coming means answer is 1. Both are 0 only, answer is 0 in OR operation. So here when we are doing 0 or 0 or 0 means answer become equal to 0. Correct. So I am writing that matrix here. The matrix, the first element we got, that is 0. I am writing first element 0. Now same way we need to multiply R1 with C2, first row with the second column. Okay, the same row, but here we are choosing the second column here, column number 2. So first element with the first element, 0 multiply 1, that is 0. Or second element with the second, 1 multiply 0, that is 0. Or third element with the third, 0 multiply 1, also 0. So what will be the answer? Equal to 0. So here the second elements we got, that is 0. Now same we are doing first row with column number 3. Correct. First row with column number 3. Column number 3 means this is the column number 3, 0, 1, 0. So 0 multiply 0, 0. Or 1 multiply 1, 1. Or okay, 0 multiply 0, that is 0. So what answer we are getting? 0 or 1 or 0 means at least 1 times 1 coming means answer is 1. That is what the operation I told here. See, 0 or 1 means it is 1. Complete 0, answer is 0. So we can say 0 or 1 or 0 means answer is 1. So the third element is 1. So first row operation done now. Now we will go to the second row. Okay, we will go to here second row. So second row multiply with the column number 1 first. Okay, same thing we are doing with the row number 2. So row number 2 with the column number 1. So first element multiply with the first element here. So 0 multiply 0, 0, or second element 0 multiply with the second element here, that is 0, or third element with the third element. So here 1, here also 1. So 1 multiply 1, it is 1. So answer will be 1. Correct? 0 or 1 means 1. One of the one element 1 means answer will be 1. So we can write 1 here. Now similar way we can go to the R2C2 and R2C3. We can continue. So we will go to R2C2, correct? R2C2 means 0 multiply 1, that is 0, or 0 multiply 0, that is 0, or 1 multiply 1, that is 1. So totally answer will be equal to 1 here. Hope you understood that one. Now similar way we can continue the R2 with C3. We can calculate R2 with C3 means 0 multiply 0, that is 0, or 0 multiply 1, that is 0, or 1 multiply 0, that is 0. So answer will be equal to 0 we are getting. So 1, 1, 0 here. Now after that we will go to with the third row. Okay, once you finish, go to the third row. Row number 3 with the column number 1, row number 3 with the column number 2, row number 3 with the column number 3. So I will write the answer here. You can try that one. So we will get 0, 1, and 1. So what is the MR power 2 matrix we are getting is 0, 0, 1, 1, 1, 0, 0, 1, 1. Now similar way we need to calculate MR power 3 matrix. Okay, so we can go to that now. MR power 3 matrix. Okay, so what is MR power 3? Actually MR power 2 matrix Boolean product with MR matrix, that is MR power 3. MR power 2 just now we got. So multiply with that with MR. So we will get the MR power 3 matrix. So what is MR power 2 matrix just now we got? That is 0, 0, and 1. Here we got last 0, 0, 1, and 1, 1, 0, and 0, 1, and 1. Correct? This matrix. Now multiply with the MR matrix. Boolean product with MR matrix. What is MR matrix here? 0, 1, 0, then 0, 0, 1, and 1, 1, 0. Okay, already here the MR matrix. Okay, now we are starting again the same multiply Boolean product we need to calculate here. So these are the first row, second row, and third row. Here we have column number 1, column number 2, and column number 3. So first row multiply with the first column here. So R1 C1 equal to. So first element here multiply with the first element here. 0 multiply 0, 0. Or second element here multiply with the second element here. 0 multiply 0, that also equal to 0. Now third element with the third element. 1 multiply 1. Correct? So 1 multiply 1 means answer is 1. So 0 or 1 means answer is 1. So first element is 1 here. So I can write the answer here. That is the first element is 1. Now R1 with the C2 we can do. First row with the column number 2. Column number 2 means this is the column number 2. So 1 multiply 0, that is 0, or 0 multiply 0, 0, or 1 multiply 1, that is 1. So second element we got 1 here. Now same way R1 with the column number 3, correct? So first element 0 with 0, 0, or 0 with what multiply 1 means 0, or 1 multiply 0, that is 0. So answer will be 0. So third element is 0. Now similar way you can continue R2 with C1, R2 with C2, correct? R2 with C3, then R3 with C1, R3 with C2, and R3 with C3, so that you will get the correct answers, matrix entries. So you will get like 0, 1, and 1, 1, 1, and 1. These are the elements in MR power 3 matrix. So we got MR power 2, MR power 3, and MR matrix. Now we are writing matrix of the transitive closure. So MR star. R star means the transitive closure matrix. M means the matrix, R star means the transitive closure. So matrix of the transitive closure. What was the rule? MR or MR power 2 or MR power 3 here. Okay. So equal to, what was the MR matrix we got? MR matrix means the first matrix we have 0, 1 and 0, 0, 0, 1, 1, 1, 0, or MR power 2, after that we got, that is 0, 0, 1, 0, 0, 1 and 1, 1, 0, 0, 1 and 1, or MR power 2, power 3 matrix. Power 3 matrix just now we got 1, 1, 0 and 0, 1, 1 and 1, 1, 1. Now take the OR operation, equal to the matrix, equal to the matrix. Take the OR operation. So the first element here 0, or the first element here 0, or the first element here 1. So 0 or 0 or 1. So answer will be 1. Correct? One of the element 1 means answer will be 1. Same way the second elements we can take the OR operation 1 or 0 or 1. So what will be the answer? Equal to 1, because 1 or 0 or 1. So answer will be equal to 1. Now similar way you can take the third element, continue fully 0 or 1 or 0. So answer will be 1, because one time 0 or 1 or 0 means answer will be 1. Now similar way you can continue all the elements. Okay, you will get the matrix 1, 1, 1 and here 1, 1 and 1. So this is the matrix of the transitive closure. We are calling it as MR star. Okay, MR star we got MR star equal to 1, 1, 1, 1, 1, 1 and 1, 1, 1. Now from here I want to write the matrix, so I want to write the transitive closure. Okay, my question is I want to write the transitive closure. Okay, without matrix. So R star equal to, this is MR star. M means the matrix of the transitive closure, but I want to write the transitive closure by using the ordered pair. So R star equal to the set. Okay, what is our set actually in our question? In our question set is 1, 2, 3. Correct? This is our set 1, 2, 3. So this matrix just change into ordered pairs. So 1, 2, 3. 1, 2 and 3. So what are the elements? 1 present, 1, 1. We have the element 1, 1 ordered pair, because here binary number is 1. Okay, all the 1 elements we can take it 1, 1 and 1, 2 is there, 1, 3 is there, then 2, 1, then 2, 2, because all the entries are 1. So we need to write all the ordered pairs 2, 2 and 2, 3. Then we have 3, 1. Then we have 3, 2. And then we have 3, 3. This is the transitive closure of that relation are given in the question. If it is asked matrix of the transitive relation, we can stop here MR star. But in our question it is asked what is the transitive closure of the relation, not matrix. Find the transitive closure of the relation. If it is asked matrix of the transitive closure means we can just find the matrix of the relation, transitive closure. Hope you understood this question. We will go to the next one now. Question number 3. That question from section number 3.2. Question from section number 3.2. So this is a SQL related question, structured query language. We studied in the 3.2 section this one. Given student mark is given in the mark database is given in table 1. See, our table is table number 1. Answer the following question. Okay, you can see in the table 1 what are the field in the table number 1. Student ID is there, student name is there, and roll number is there, and total mark is there. So we have 4 fields are there, 4 field, correct? Student ID, student name, roll number and total mark. That means the 4 tuple, because 4 field means 4 tuple we have in the database. And we have some data are there. Student ID is given in the first column. Column number 1 it is given student ID, column number 2 it is given student name, column number 3 roll number, column number 4 total marks are given. Now what is our question? What is the output of the following SQL statement? One SQL statement is given. What is the output of that SQL statement? That is the question. So what is the SQL statement here? Select. Selection is the operation. Select the roll number and total mark. That means select the column roll number and total mark. Roll number means the column number 3 and total mark means column number 4. Select these two columns. From where we need to select? From the table 1. Our table name is table number 1. So from table number 1, select the columns roll number and total mark. Now selection 1 criteria is given where total mark should be greater than 905. Okay, 905. Total mark more, it should be more than 905. So what are the output we are getting? Okay, or what are the data we are getting? What are the tuples we are getting? 4 tuples or 2 tuples we are getting. Okay, that is what our question here. So here we are using the selection operation, and from selection operation one condition is there, total mark greater than 905. So we will see that one. So you can see the table number 1 and you can see the total mark column, that is the column number 4. Column number 4 for 905 greater than, more than 905, just select. See, first one is not possible because it is 900 only, so not selected. 820 not selected, 850 not selected, 950 it is selected, it is more than 905. 910 it is selected, it is more than 905, and 864 it is not selected. Correct? So what will be the answer getting? You can see what will be the answer. I will write here. So a part of the question, the output, correct? So the output becomes, so what are the select roll number and total mark. This is what our question, correct? Select the column only roll number and total mark. So we can write that one, roll number. What is the roll number corresponding to this one? 110, correct? So we can write 110, comma, what is that mark of that student? 950. So this is the first answer, 110 and 950. Now the second one, okay, 111, 111. Second record is 111, comma, what is the mark of that student? 910, correct? Only we are selecting these two, selecting the roll number and total mark under the condition total mark should be greater than 905. So we are writing the output 110 and 950. Hope you understood the A part of the question, correct? Okay, now let me go to the B part of the question. So what is the B part? What is the table? What is the table obtained when the projection P14 is applied to the relation in the given table 1? We need to apply the projection P14. Okay, P14, P1 comma 4. So P14 means, what is the meaning? Just keep, okay, just keep column number 1 and column number 4 and delete another columns. Okay, delete other columns. That means column number 2, column number 3 delete, and we need to delete the double entries also. So we will go to the projection, how the answer is getting. So what is the column number 1? Actually column number 1 is student ID, correct? So student ID will be there. And what is the column number 4? We can see column number 4 means total marks, correct? So total marks. So we will keep only these two, that is the meaning projection. Keep only these two columns, remaining columns we are deleting. So we can write the answer now. Student ID, what are the student IDs? 1, 2, 3, 4, 5 and 6. So I can write 1, 2, 3, 4, 5 and 6. Now the corresponding marks also we are writing total marks. So 900, 820, 900, 820 and 850, 950, 850 and 950, 910, 864, 910, 864. So this is the projection P14. Okay, so there is separate question. What is the projection P14? We are getting, that means just project only column number 1 and column number 4. All other columns we are deleting here. So I hope you understood this one. What is the SQL statement output and what is the projection. Okay, this section 3.2 we studied 3 operation. One is the join operation. We studied that section. Join operation we studied, and we studied what is the meaning projection, correct, and we studied what is the meaning selection operation. Okay, so this is just revising this question. We are revising only join and projection operation. Okay, now let me go to the question number 4. Question number 4 from section number 3.5. Find the equivalent class of 4 modulo 2. Okay, modulo 2, that means the congruent class of the number 4 under modulo 2 operation. Okay, we need to calculate this suffix 2. Okay, means what is the meaning this one? Modulo 2. Okay, so the equivalent class of the number 2 under modulo 2 we need to calculate here. Then B part, find the partitions. We need to calculate the partitions of the congruence modulo 6. We need to calculate the partition. So let me answer the first part of the question, A part of the question. Okay, what is the equivalent class of 4 under congruent modulo 2, correct? So what is the easier way we studied? We start with the number 4 here in the middle, number 4. Okay, after that just add the modulo number 4 plus 2. Okay, 4, then 4 plus 2, I am writing the step here, 4 plus 2. Again what we are doing, 4 plus 2 number adding with again with the modulo number 4 plus 2 plus 2, like that it is continuing. So I can write the answer here. Okay, so what I did in the first step, 4 plus 2, correct? So 4 plus 2 means we are getting 6, second number. Now from 6 again add 2, 6 plus 2 modulo number, correct? So 6 plus 2 means we are getting 8, then 8 plus 2 we are getting 10, like that it is continuing. Now the negative part, here we are doing subtracting modulo number minus 2, correct? So 4 minus 2 means that is 2. Then again subtracting 2, we have 2 minus 2 means 0, again subtract 2, 0 minus 2, that is minus 2, like this continuing. Okay, so this is the equivalent class of the number 4 under the congruence modulo 2 operation. Okay, hope you understood that we are doing. Now the second part of the question, find the partitions of congruence modulo 6. Find the partitions of the congruence modulo 6. Okay, so we will go to that one. So partitions of the congruent modulo 6 means the partitions of the equivalence relation congruent modulo 6. Okay, the relation is congruence modulo 6. So we will go to the second part of the question here. Now like these questions, when we are taking the full set, you know what is the meaning of partition actually, correct? What is the meaning of partition actually? When we are taking the intersection of the partitions or subsets, AI intersection AJ, always it should be empty set. And when we are taking the union, A1 union, A2 union, A3 union, we need to get the full set, correct? The A set. Then we are telling AI are the partitions of the set A, correct? So that is what we are doing here, the partition. What are the partitions of the partitions under this question of congruence modulo 6 here? So when we are starting here, the main set, this congruence operation we are taking in the set of integers, correct? So here A set means the set of integers Z, we are representing Z. What is the integer set actually? 0, 1, 2, 3, 4, 5, 6, like this continuing, correct? Now also minus 1, minus 2, minus 3, minus 4, like this is continuing. Okay, now we are going to the congruent class or equivalent class of the numbers. First we are taking this number, 0 number. So just to calculate what is the equivalent class of 0 under the congruent modulo 6, correct? So suffix number 6. You know how to write this set. The middle number we are writing 0. Then 0 plus the modulo number, 0 plus 6, that is 6. 6 plus 6, that is 12. 12 plus 6, that is 18. Like that it is continuing, correct? Now subtracting the modulo number here, 0 minus 6. So minus 6. Minus 6 minus 6 means minus 12. Like that it is continuing. So first write the number 0, then add the modulo numbers 0 plus 6, 6 plus 6, 12 plus 6. Same like subtraction also, 0 minus 6, minus 6 minus 6, like that it is continuing. Now go to the second number, okay. You can go to the second number here. Now it is 1. So equivalent class of number 1 under the modulo 6 equal to the set. First element is 1 here. Then 1 plus 6, that is 7. 7 plus 6, that is 13. Like this continuing. Now this left part you can see 1 minus 6, that is minus 5. Minus 5 minus 6, minus 11. So like this is continuing, correct? Now the third one we can go. Third element, that is 2 under modulo 6, correct? The next element is 2 here. 2 under modulo 6. So we can calculate. The middle number we are writing is 2. 2 plus 6, that is 8. 8 plus 6, that is 14. Continuing. Then the left part we can see 2 minus 6, that is minus 4. Then minus 4 minus 6, minus 10. Like this is continuing. Now the next one, congruent class, number 3, correct? Number 3 under the modulo 6, correct? So equal to, we can write 3. 3 plus 6, that is 9. 9 plus 6, 15. Like this continuing. And the negative part, 3 minus 6, minus 3. Minus 3 minus 6, minus 9. Like this is continuing. Now similar way we will do the next also. Congruent class 4, okay, under 6 equal to, the middle number is 4. 4 plus 6, 10. 10 plus 6, 16. Like this continuing. Then here in left part, 4 minus 6, minus 2. Minus 2 minus 6, minus 8. Continuing. Now congruent class 5 modulo 6 equals, we can go to the 5. 5 plus 6, 11. 11 plus 6, 17. The left part we can see minus 1, minus 7. Like this is continuing, correct? Now, so we wrote up to 5. Now when we are going to 6, the number 6, you can see what happened. 6 under congruent modulo 6 we can write equal to 6 here, then 6 plus 6, that is 12. 12 plus 6, 18. Like this continuing. And left part 6 minus 6, 0. 0 minus 6, minus 6. Minus 6 minus 6, minus 12. Like this continuing. Now what happened this one? Actually this one is same as the equivalent class 0, correct? You can see this one is same as this one. Okay, now this cycle is repeating. If you are finding more 6 equivalent class, you will get to 0. 7 means you will get to 1. Like that it will continue that one. Okay, so this is same as the class 0 under modulo operation 6. So no need to go now, because the partition means disjoint equivalent classes. Okay, disjoint equivalent classes, that is form partition of the set A. So now we can write the answer. Okay, so we will write the answer here. Partitions. Okay, what are the partitions? Actually partitions means what I told here, disjoint. Separate. Disjoint means separate. So disjoint equivalence classes, correct? Disjoint equivalent classes. So what are the disjoint equivalent classes? You can see equivalent class 0 modulo 6, equivalent class or congruent class of 0 modulo 6, because the operation is congruence operation. That's why we are calling congruent class or congruence class modulo 6, or equivalent class 0 under the congruence operation, congruence modulo 6 operation. Both are same. So first one is 0. Then equivalent class 1 under 6. Then we got equivalent class 2 under 6 modulo operation. Then 3 modulo operation 6. Then we got 4 modulo 6. then we are getting 5 modulo 6, correct? Now 6 means it will repeat same 0. So disjoint means separated, okay? Separated things 0, 1, 2, 3, 4 and 5. So these are the partitions of that equivalence relation congruent modulo 6. Hope you understood that one. See why we are telling this one partition. You can see if you are taking the intersection of this set, for example congruent class 0 and 1, if you are taking intersection, there is no element common. 0 and 1, there is no element common, correct? Same 1 and 2, there is no element common. 2 and 3, there is no number common. Same like if you are taking any pair of that congruent classes, there is no element common. Intersection should be empty set, okay? AI intersection AJ should be empty set, 5 set. What is AI and AJ? The first one we are calling A1 set, this is A2 set, this is A3 set, this is A4, this is A5 and this is A6. We have 6 partitions here. If you are taking any 2 partitions intersection, answer will be empty. There is no common element. You can see this set, okay? All these 6 set up to here, there is no common element. That is the first one. Then if you are taking union, A1 union, A2 union, A3 union up to A6 union, you will get the same set A. The original set A you will get it. For example, here you can see what are the partitions. See what are the union of these sets. You can see 0 here, 1 here, 2, 3, 4, 5, then 6, 7, 8, 9, 10, 11, like that it is continuing. So you will get this part 0, 1, 2, 3, 4 like that. Now negative part you can see minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10, minus 11, minus 12. That means the negative part. So when we are taking the union, you will get the full A set, the original set A equal to. So that is why the second condition also correct, first also correct. If it satisfies these 2 conditions, we are telling the partition, correct? We are telling the partition of that set. So what are the partition in our questions? The equivalent class 0, equivalent class 1, equivalent class 2, 3, 4 and 5. Hope you understood that question. So this is the idea from the section 3.2 to 3.5 section. Hope you understood all the questions. So thank you for watching. Please subscribe my channel for getting more recorded classes. Thank you very much.